If you want to do a video, let's get over with the person actually there.
Yeah, it is just my voice and my writing. Which I kind of like, but then it doesn't matter what I wear.
I'll get on my graphic too.
Were you in your pajamas when you filmed it?
No, I filmed it during lunch on Thursday. That's why you kept hearing bells.
Oh, I need a funny day.
And then after school,
Yeah, you said that's not your bell, and that's like, how'd you know?
Bunny. Why did she have bells at her house?
Yeah, I kind of had to grow my own graph paper. I was in the car, so I just like created a graph
Where's your graph paper?
You got it in there? Okay.
You should like call somebody out and like, no,
That's
no,
what my
just be like made someone think that you're like actually there like watching.
Last period they told me I should definitely just left the crib.
Your sellers is
Actually work.
Me and Chris should be in the same class. I wasn't doing why did you do you?
I'd also like to say that not only did me and Kyle beat Macintosh last Thursday, but we also done that in the process.
Don't say the S word.
You know what I mean, Kyle? And if you beat them, I'm shaking my head.
Alright. Okay, let's take a look, guys. I'm done checking homework now. Let's take a look. So, on Friday, the new thing I added was vertical stretches or compressions. So, if we had our parabola, and I'm forming a parabola with my hands right now. So, see the parabola?
I see it.
Alright, so if I vertically stretch it, it pulls it this way and it makes the parabola more narrow, doesn't it?
Correct.
If I vertically compress it, it stretches it out this way. It compresses it this way and makes it wider. If I multiply by a number greater than 1, that causes that vertical stretch. If I multiply by a number less than, between 0 and 1, that causes the vertical compression. Now, the negative, we actually say absolute value of that number because the negative just causes a reflection. So if we look at number 1, it's a vertical stretch by a factor of 2. It would take that and stretch it vertically. Number 2 is a reflection over the x and a vertical compression by a factor of 1/5. The next one is just a reflection over the x. Number 4 is a vertical compression by a factor of 2/3. Number 5 is a reflection over the x and shift up 9. Number 6 is a vertical compression by a factor of 1/4 and shift down 3. Number 7 is a vertical stretch by a factor of 7 and shift down 3. And number 8 is a reflection over the x, a vertical compression by a factor of 1/2, shift left 4, and down 2. Any questions on 1 through 8? So we're good on that part? All right, so let's see how that would look in terms of our graphs. Okay, I am going to show you this because looking at it all at once is a little overwhelming and just a big mess. Okay, so we'll start off with the blue. So y equals 2f, and I should have put of x, but I left that part out for some reason. So f of x means the same thing as y, doesn't it? So this means double your y's. So if I took this point and I doubled my y's, it would go from -2 to -4. If I took this point and doubled my y's, it would go from 5 to 10. If I double the y, it goes down to -8. And the arrow looks like it's about to go through 4, so it would about go through 8. So now I've done that, and I can connect the dots. So number 1 would look like this. It's been vertically stretched by a factor of 2. Okay, number 2, we're supposed to take our y's and multiply by a 4th. So a 4th of -2 is about -1/2. A 4th of 5 is 1.25, so I put it about there. A 4th of -4 would be -1. And a 4th of +4 would be about +1. That's where that arrow would go. And so I would connect the dots. So this one has been vertically compressed. It's been pushed down. Okay, questions about those two? All right, this one has a bunch of stuff going on. It has this -2. Well, the 2 we've already done, haven't we? So if we take these blue points and we keep in mind the negative here, that just reflects it over the x, which changes the y's to the opposite. So do you see how this point here, -7, -4 would go to -7, +4? This point here, -5, +5 would go to the point, whoops. Oh, hold on. First off, we would flip them. I haven't flipped them first. So this point would go from here to here. So it would go, hold on, there. It would go to -7, +2. And then -5, -5. No, I'm just doing the blue ones. I went back to the black ones. I am really, really sorry.
Sorry.
I am confused. I am taking these blue points and flipping them, and then I went back to the black. So that's why it went from -7 to +4. This point here would be -5, -10. This point here would be -2, +8. And then the arrow here would go to 0, -8. And then what we'd have to do to all of these is shift them left 1 and up 2. So we'd subtract 1 from our x's and add 2 to our y's. So with the blue dots, and we flipped it over the x-axis, we changed all our y's to the opposite. Then we go left 1, up 2. So -1 + 2 gives us this point. -1 + 2. -1 + 2. -1 + 2. And that's how we get our final points. Yes, ma'am?
What is it to be a compression?
The negative is a reflection. The negative causes the reflection. The 2 causes a vertical stretch.
So if there's just a negative, it will be...
A reflection every time. Okay, so now let's graph this. So it goes -8, +6, and then -6, -8, and then -3, +10, and then -6. And then we connect the dots. And it would look like that. So it's been flipped, stretched, shifted. Are we okay?
This stuff's hard.
Alright. Now on this one, the black graph is the parent graph. So I drew that in there first. And then what we do is we'll take, and I'll walk you through every point. Every point on this one gets multiplied by 3 and shifted down 3. So 0, 0. If I take the y value at 0, 0, what is 0 times 3? 0, and it shifts down 3. Take the y value here, which is 1. The y value here is 1. 1 times 3 is 3, shift down 3. The y value here is 1. 1 times 3 is 3, shift down 3. Do you see where those points come from?
Times 3 minus 3.
Yep. Okay. On these, the y values get multiplied by a half. So when they get multiplied by a half, do you see how it makes it look like this? They get multiplied by half. Half of 1 is a half. Half of 2 is 1. And then we have to shift it. What does this do?
Right 5.
Right 5. write 5. So this is our final right here. So first thing we do was half, and that gave us that first one, and then we go write 5. Now, this is the parent graph. The negative is going to flip points. So this point comes up here, this point comes down here. The 2 is going to double them, and then up 4. So this point goes from 1, double it 2, up 4. 0, double is still 0, up 4. This point flips down here. Double and up 4. So down here and up 4. Okay? Are we good? Okay. All right, today we're going to look at our last type of transformation, and that's horizontal stretches and compressions. So this is it. We've done translation, so we did shifts, up, down, left, right. Then we did reflections over the X and the Y. Then we did vertical stretches and compressions, and today we're going to do horizontal stretches and compressions. Okay, so this is it. Last day of transformation. So we're going to do horizontal stretches and shrinks or compressions. So when we look at our horizontal stretches or shrinks, whenever anything is grouped with the X, we always think opposite. So when we had like f of x plus c, we did the opposite of that. So instead of going right c units, we went left. Or let's actually use a number. If we had this, we would go left 2. If we had this, we would go right 4. You always do the opposite when it affects the X. Well, here we have the C multiplied in here. And when we think of this, we always think opposite. So if this were Fy equals f of 2x, well, we would think, ooh, multiply by 2. But what's the opposite of multiply by 2? What is the inverse? Good, dividing by 2. And isn't dividing by 2 the same as multiplying by a half?
Yeah.
So if this number is greater than 1, do you see how it's actually a compression? Because we have to do the reciprocal. If this number is between 0 and 1, it is a stretch. When it affects the X, we always do the opposite. Now we're going to do some examples so that that actually makes sense. Okay. So the first thing I have here is the parent graph for a quadratic, which we've done like 12 times now.
Too many.
Yeah. Do you think so? Okay, so sketch that. We know what it looks like. And once again, on your test, I'll actually give you graphs. But go ahead and sketch that. Yeah, we're gonna finish it today.
Are we really?
Yes.
So that means we have no homework?
The last problem in the packet is your homework.
Wait, there's only one problem?
And then we
Is
don't
it like a
have
legit
the rest
problem?
we-
Super hard.
Is it one of those? It's a little bit.
It's somewhat of a
It like
doozy.
turns it, it looks like an easy equation, but then it turns into like a word problem, and then it goes into like this whole.
No, it's not that bad. All right.
That is the face.
Okay. So now, just like on every single one, when we investigate what's going on, we are going to make a table, and then we're never going to make a table again. So let's see what happens. Let's prove to ourselves why this works. If we plug in -4 into this equation, what is half of -4? -2. And what do we get when we square -2? 4. When we plug in -2, then we take half of that, it's -1, and square it, you get 1. Plug in 0, half of 0 is still 0. Squared is 0. Plug in 2, half of 2 is 1, squared is 1. Plug in 4, half of 4 is 2, squared is 4. Now let's not do it on this graph. Let's sketch it on this one up here so we can see how it relates. So we got negative 4, 4, negative 2, 1, 0, positive 2, 1, and positive 4, 4. Does it look like I took my parent graph and stretched it horizontally? Yeah. Do you also notice the x values here? If I doubled this x value, does it give me this point? Yeah. If I double this x value, does it give me that point? If I double this x value, does it give me that point? And if I double this one? So, do you see that what is the reciprocal of 1/2?
2.
2. And in each case, we multiplied the x's by 2. This is a horizontal stretch by a factor of 2. So you see how it actually does the opposite of what it looks like? Or what you might be thinking?
You know, to me, the horizontal stretches look like vertical conveyor.
I was just
They
about to say
do.
that.
They do, especially on the parabola. Especially. A little less on some other functions, but especially on the parabola. Actually, a horizontal stretch by a factor of 1/2 is, well, by a factor of 2 is the same as a vertical compression by a factor of 1/4. And we'll connect those two together next year. Yeah. We don't have to do that this year. Yeah. Okay. All right. So, what do we think is going to happen because of that 2? Yeah, we're going to divide our x's by 2. Dividing the x's by 2 is the same as multiplying by a half. So, instead of being 1, 1, it's going to be a half 1. Instead of being the 0.24, it's going to be 1, 4. Instead of being the point -24, it's going to be -1/4 and negative a half 1. It shrinks it. That is a horizontal compression. By a factor of what?
2.
1/2. We use the reciprocal because it got smaller. It was compressed. If it's compression, it's always going to be between 0 and 1.
Yeah, I'm sorry. I get that.
All right, this one. What does the 1/4 do?
Multiplies it by 4.
Multiply by 4. And then what does this do? Down 1. Okay, so that's what we'll do. This was 1, 1, so now it's going to be 1, 4. Excuse me, 4, 1. But then we go down 1. So it's going to be 4, 0. This point right here was 2, 4. So now it's going to be 8, 4. But we go down 1. 0, 0. Times 4 is still 0, 0, but down 1. Negative 1, 1 becomes negative 4, 1, but down 1. Negative 2, 4 becomes negative 8, 4, but down 1. And then we get this nicely stretched parabola. It was a horizontal stretch by a factor of, and then shift down 1. Okay, the next one is a U-try. U-try, the last one on that page.
Whoa, you give us a hard
I can do this. Why are there a bunch of parentheses?
To show it's all grouped.
polygroups. Here we go.
It's just 2.
Alright. First off, no thinking out loud.
Hey, this one's harder. I was laughing at my hands. They made a funny joke. No, it's here.
I did it.
I did it. Was easy.
Yes. Okay, so do you get a horizontal compression by a factor of 1/2? And then you shift right 1. So when I horizontally compress by a 1/2, it turns it into the blue, right?
Yes.
And then every point has to shift right 1 unit.
I got that one. I'm confused. Yeah, what finally got there.
Okay, this is just the compression by 1/2. And then the red is the final. The red is after we shift it right 1. So we compress by 1/2 and shift right 1.
I almost got that right.
Oh yeah, it's divided by 2.
All right, are we okay? Yes, Andrew?
Are we gonna have to name these when I press, like, what happened to the graphs, like?
Yes, you'll have to be able to do this.
Okay, so I go. Okay, I got it. Alright. Oh my gosh. Because couldn't they all be, like, vertical or horizontal? Like, does it matter which one you
It does matter. There's a difference between this and this. Do you see that on this one, the 2 is outside? It is not being squared. Do you see that this one, the 2 is actually being squared also? The 2 is grouped with the x. Do you see the difference? The 2 is grouped with the x, the 2 is not.
So when it's not, it's
When it's not, this one's a vertical. When it is, that one's horizontal.
okay, thanks.
Okay. All right. You try to describe 1 through 8. Hopefully you can remember from 6th grade that 0.125 is the same as 1/8. That might help you.
I learned it.
I don't think I was there. I think I missed that day. I'm just kidding.
Well, then maybe I should add that to the next quiz. If we don't know our eights.
I remember.
Oh, okay. All of a sudden.
Not a blur. Fog is lifting.
Okay, gentlemen. Did they injure you, Ryan?
You just bit me. That was mad.
Did you seriously? Okay, please try 1 through 6.
Did you know that Jade's pencil is actually a comedian? I got the one you did. You tried.
Under 18
I can
I
help
didn't
you.
do that. I was just.
I mean, bro, I mean.
I was little like.
Do we have to graph it?
Look at my mom that time.
Leave it coming down.
Maybe I should cut from theirs.
We'll use that.
No, but it was down. You don't have to. I'll fix it.
Huh?
Miss Willoughby, can we abbreviate horizontal?
With what?
Just HOR? Well, I'm not gonna make it HORI or HORZ. HOR. Because that's what you were writing.
Yeah.
It's a lot easier to write horizontal.
Here with the square.
Crazy day.
Say that again.
Sometimes Ryan might just come up and bite you in the arm. Sometimes life's name is Kyle. Miss Willoughby, I forgot what the square graph looks like.
I don't know either.
I'll Google it.
It's in your packet.
Oh, it is?
Like, we did it. First couple examples of the day. Is this one right?
It's a vertical stretch. I mean, a horizontal stretch.
Why is that?
It's being square.
Oh, okay. I was like, why is there one vertical? What the heck?
This game is rolling in.
Oh, there's a reflection. Okay, let's take a look. Number 1 is a horizontal compression by a factor of 1/5. Number 2 is a horizontal stretch by a factor of 8. Number 3 is a horizontal stretch by a factor of 4. Number 4 is a horizontal compression by
Finish the page.
a factor of 1/8. Number 5 is a horizontal compression by 1/3, and we shift the function up 1 unit. Number 6 is a reflection over the x, or horizontal stretch by a factor of 2, and a shift right 3 units. Okay, how are we doing?
I feel a little bit more confident.
Good, good. Yes.
How do I know the difference between a stretch and a compression?
I can help him out here. Want me to?
Yeah, I need that.
Sure, go ahead.
Okay,
Matt.
so look. So when you have a stretch or compression or horizontal.
I just want to know both of them.
Okay. So a horizontal stretch is when it's directly multiplied to the x,
Okay.
but a vertical stretch is when it's multiplied outside.
Out in front.
Out.
Yeah.
So
He's
outside
right.
the parentheses.
Correct.
How about that?
So, see on this one, like down here, the 2 is inside with the x. If it was vertical, it would be out here. That's a vertical stretch. This is a horizontal compression. Do you see the difference? 2 out in front, 2 inside. All right. Now, here's our random function for the last time. And these are the points on that random function. This says find y equals f of 2x. Well, it's inside, grouped with the x. That's horizontal. We do the opposite. What is the opposite of multiplying by 2?
It's horizontal
Multiplying by a half. So we take all of our x's here and multiply them by a half. On this one, what do we multiply our x's by?
2.
Good. Do it.
Legitly? And do we
Legitly.
graph it on
Graph it
graph it on these
on the
graphs?
graphs provided.
Or the big one?
No, the ones below.
Okay. What? I wasn't even trying to make a joke there.
Yes, Ron.
Okay, you can put that. we multiply the y's by 3 or the x's? I mean, y's by 1/2?
It affects the x. It's grouped with the x. It affects the x. The x's, not the y's. These numbers are grouped with the x, so it's going to affect the
I
x.
just think that, like, because of y equals,
Yep.
that's what it trips me off.
But this is when it affects the f, the y, because f of x means y, so this is 2 times your y. This is in with the x, so it affects the x.
So when it's vertical, you multiply it or whatever by the y. Okay. Is your mind just like?
No, I have a terrible headache,
Oh.
and I'm just trying really hard to fake it.
Oh, sorry.
It's okay.
Time to go 16.
This
really is
a easier unit.
What's this a little?
That's a horse
I'm glad you liked it.
Well, aren't we all special?
Are we gonna get a study guide just for
Yeah, I have 2 study guides. One is on the back of something we've already done. Remember that one page? Yep.
It's
And
that
then,
first packet we got.
Yep. And then I have another one. So I actually have 2.
I see.
Okay. So here we go. How's y'all do? Does the first one appear to be horizontally compressed? And the second one is horizontally stretched. Any questions?
I didn't get what you got.
I got what you got.
easy?
With a Z.
Oh, I see what I did.
Good. Fabulous.
Simple, forgot the negative kind of thing.
Oh. Huh? Fabulous.
Ryan, you took it way too far.
The orbit commercial.
One Z is fine. One Z is fine. That's fine.
Okay. Okay, now top of the next page is a summary of everything. This is our summary of transformations. Let's see what you can do without looking back at your notes. Give it a try.